We'll start without push and pop, and then we'll add it. So first thing, we need our setup function, right? So I'll go ahead and create that function, and we need our draw function, so I'll go ahead and create that function. So we've got our voids, right? Keep in mind the void means that when this function runs, it is not going to return anything in the program, right? It's not going to kick any results back. It's just going to do whatever it does, and that's it. All right. So now inside of here, I'm going to do background 0, and I'm going to do size, and I'm going to do 1024 by 576. The exact size doesn't matter. This is just the size for this example. I'm also going to put one more argument, p3d. This is going to make this into a 3D canvas in processing. So don't forget the semicolon. And then I'm going to do this all with that like slightly obnoxious but very stereotypical bright green that you saw, and a lot of that was seen in a lot of like 80s 90s 3D rendering, and I think it works well. I'm going to do no fill because I don't want this to have a fill. I want you to be able to see through it because that's also very sort of iconic of that idea of this 3D rendering from the retro ages. I'm going to start out with box. So this is going to draw a box, and it is going to be 200 by 200 by 200. Notice 3 parameters that we're passing through because we are doing it in 3D. So this is not going to be exact, but I'm just going to show you. So if I run this, all right, a little wonky. Okay, I need to use translate to move it down. So translate, and then it helps if you spell it right. Okay, there we go. And I'm going to do width divided by 2 and height divided by 2. That way it's right in the center. And then 0. Because this is 3D, we need 3 arguments. So I'm translating it to the center point on the width and height, and as far as like depth, like the Z coordinate direction, 0. Like don't move around on the Z axis. So now if I run this, it should be in the middle. Okay. Let's add a little bit of rotation. So rotate Y. So I'm going to rotate it on the Y axis. All right. I could put in any number in here. It doesn't really matter what goes in there. Well, I mean, it does. You can see it. What I really wanted to do is I want it to, like, rotate live, right? Because that's what you see in sort of these iconic, stereotypical 3D things, right? Demonstrations. So if I do that, then here I can pass angle in, and then here I need to actually change the value of angle. So angle is going to plus equal itself, all right, with just a little change, a little slight change, right? So this should change it over time, so our cube should rotate. All right, there we go. Notice that it's becoming the cylinder, and that's because I put the background in the setup. I did that intentionally because I think it's neat, but I'll change it in a moment. I'm gonna do one more thing. I'm gonna add one more angle in here just because, and I'm going to copy and paste this in here. Now this will be X, and this will be 2, and this will be 2. Now it's going to rotate in 2 dimensions, right? That's cool. Keep in mind there is one more dimension because this is 3D. There should be a Z plane that we can rotate this on as well. So I'm going to do one more of these. Now, because all of these values are basically changing the exact same way, I could just use one variable, but by having separate ones, then I can also manipulate them in different ways. Right, so now we have this interesting thing that's going in all different ways. It's a little bit hard to tell what's going on because, again, this background, so maybe I move this background into the draw loop. There we go. Now we can see how it's rotating in all 3 different spaces, right? And it's right, a little wonky. Okay, so I'm going to go ahead and delete these back down to angle 1 before doing the next part, because I'm going to show you sort of a series of things. So now we can do this, and like you should you should play with this as we move along, pause things, try things out, experiment, etc. So the next thing that I want to do is I want to make another box. I'm going to make a smaller box that's attached to this box. So we're going to do another translate. Alright, well actually no, I'm not going to translate yet. I'm going to make another box. This box is going to be 25 by 25 by 25. Alright, so if I run this, okay, now I've got a box inside of a box. Alright, what if I add in a rotate X command function, whatever, before running the box? I'm just going to do it by 0.5. Now if we look at this, right now it's like tilted 45 degrees, right? What if we translate this, right? I want to move it, so now it's going to be 100, 0, 0. Alright, go inside the parentheses, okay? So now if we do that, now it should be attached, there we go, to like the side, right? And you can see it's attached to the side as it rotates around, okay? We could play with other things too, so instead of maybe this being by 0.5, maybe this is actually by angle, right? We could use that same variable in there. And now you see we've got the little box attached to the big box that's also rotating. Right? What if we want to add another box? Alright, so let's say that I want another box on the other side, right? Hang on. Okay, so we've got this box here. What if I want a box on this plane, on the other plane, right? So one here and one there, right? What would we do? So what I would need to do is make another one, right? So if this is 100, then the other one would be negative 100, right? Is that right? Let's look. It's not. It's in the middle. So why is this one in the middle when the other one is over there? And notice also the rotations are slightly out of sync. Are they out of sync? I think they're out of sync. Yeah, they're slightly out of sync, right? Why are they out of sync? So keep in mind that these transformations, this translate and this rotate, it's cumulative. It adds up. Oh, that was wonky there for a moment, right? So this needs to be negative 200, right, to go further over. And actually, I wouldn't add a rotate X here at all because the other one is already rotating. So it makes it a little bit tricky, right, to try to keep these things in mind, to try to keep up what is the cumulative change happening over time. All right. However, through the power of matrices, all right, what I can do instead is I can just do a push matrix here, right? We're sort of setting a checkpoint of like where it's going to like have sort of this save spot, okay? And then here I can say pop matrix. All right, so now if I run this, all right, what's going to happen? Right? So this one is staying still, and it's pushed out an extra 100 degrees that way, or 100 units that way, because it is no longer cumulative. Or it is cumulative, but it's jumping back to before I made these changes. So now I don't have to worry about how much it should be in relation to this. I can just think about it in relation to the origin point. Right, and then I can also add this rotation back in here if I want to, and we're good, right? So that can be convenient in how you think about some of this, right? It gives you a little bit of a shortcut and less stuff that you're having to worry about, right? And that's good because you have enough stuff to worry about, right? Now, if we want to make things more interesting and a little fun, what if we add more boxes, right? So I'm going to use push and pop quite a few times. I'm going to copy and paste that because then I can go in here and I can change a bunch of these, right? I can make another one. Maybe this one is at 0 and this one's at 100. And maybe I make another one and this one's at 0 and negative 100. Delete the extra 0, right? And I can start to play with this, right? What I can also do is instead of just translating, I could play with adding angles in here, and there's all sorts of ways that I can play with the values in here, right? And slowly over time, oh, because it's small, right? I might actually like multiply this by 10 so that way you can actually see what is happening because it's so slow. If I wait long enough, it'll happen, right? So now if we run this, Can you see it? Is it going? Yeah, I think it's going. Even by 10 might still be too small. I might need to do it by 100. Oh yeah, you can see they are starting to move around, right? So you can play with all of these. You can play with these values, right? Maybe multiply this by angle, right? So you could just play and see what happens. Make a bajillion little cubes, all right? So I'm gonna go back to before I added all of those extra cubes, all right? We'll go there. And instead I'm gonna create a function. Oh, did you see how wonky that was getting? I'm gonna create a new function. And so void, or a new method, or whatever you want to call it, varies by language. And I'm going to call this make cube, because we're going to make cubes. Alright? And I'm basically just going to take this code and put it in here, right? And then, so I can delete these. And now what values do I want to put in there, right? So maybe I want to do something that relates to the positions. Okay, so I'm gonna do floats. I'm gonna say lock 1. That's gonna be short for location 1, and float lock 2, right? And I could even do one more, float lock 3. All right, then of course I need to lock 1, lock 2, lock 3. All right. And then from there, right, I can have fun. Right, so make cube. Oh my gosh, Mac cube. Make cube. Okay. And then here I can have the 100 and the 0 and the 0. And I can do another one. Right, and we can get back more or less the same thing that we already had, right? But by having a function, why are you angry? Missing, oh, semicolons. The issues with bouncing around between different languages. Incomplete statement, extra 3, translate. Why don't you realize that this is 3D? Oh, I don't like that. I don't realize that it didn't realize that this was 3D. Okay, well, it behaved better the other day. Not important. If it lets you have a third one, then add a third one. If it doesn't, like, whatever. Now, the other thing that you can do is you could also do stuff with mouse values, right? So we could instead say mouse X here, and this can be fun, right? And so now, right, these jump around based on the mouse moving. Right, now that moves really fast. What I also might decide to do is I might decide to map the value. So maybe I do map. And map is its whole other thing, right? But you're able to set one set of values, like mouse X, and then relate how that's going to be to other values. So you can play with this. I'm going to do mapping it to width -2 times pi, and again, and then 2 times pi, right? And again, like I'm not going to really go into exactly what that does. You can look in the map if you want a little bit and kind of play with it. So now if I move this around, you can see it's much more gradual. I was using the wrong axis earlier, wasn't I? Let's try that again. Let's just show you the difference. I'm going to do this. All right. And this time it's going to be mouse Y, but without the map function. And you can see how the two differ, right? So I can do this nice and slow, right? It's still a little tricky because if I move the mouse on the y-axis, it jumps around. Now if I do the y-axis, see how fast it goes? Right, even if I go slow, it still jumps quite a bit, right? And it's quite jumpy, right? Whereas on the mapping, you can see how it's. If I can keep my mouse still on the y-axis. Anyways, you get the idea, right? So play with those. That's interesting. Of course, add in a loop. So instead of just doing this, we could create a loop where it creates a whole bunch of them, right? Or we could just make more of these, right? But there's a variety of things that you can do. You can try out. You could add conditionals. You could add in the idea of like the random walkers into this, right? So just play a little bit with 3D before moving on.